Hello Algebra 2 students. In this document we are going to review exponents and logarithmic functions. So we're going to start with graphing. And I'm going to skip around a bit so that you have some practice problems to do on your own. I'm going to make one video that will go through a lot of the problems, skipping over a few for you to practice, and then you can check those practice problems with a second video. So we're going to start with y equals 3 to the x plus 4. Now you can put that in your calculator, 3 to the x plus 4, and what you're going to notice in your graph is that the graph is shifted to the left, which is actually what happens when you change the x. You would expect all of the points to be shifted to the left 4, so that normally our important points would be -2, -1, 0, 1, and 2. But everything is shifted to the left 4. So if you look at your table of values, the points that we're going to want are 4 less than those. So instead of starting at -2, start at -6, and instead of ending at +2, we're going to end at -2. So we're going to copy these points from -6 to -2. Okay, -6, -5, -4, -3, -2. Now if you're doing this without a calculator, you can plug -6 in here. You get -6 plus 4, which is -2, and 3 to the -2 is 1 over 3 squared, or 1/9. But on the calculator you will see that it also has the value 0.1 repeating, and for the sake of graphing, 1 decimal place is enough. Alright, the next one, when you put -5 in here, you get 1/3, which on your calculator you see is 0.3 repeating, and again 1 decimal place is fine for graphing. When you plug -4 in, you get 3 to the 0, and anything to the 0 is 1. And then when you plug in -3, you're going to get 3. And when you plug in -2, oops, things are moving around, you're going to get 9. And again, you get all of that also on the calculator here. So then we need to plot those points. So you can see here, I did my best on the smartboard to plot the points from the table of values here. You can pause the video for a minute and plot the points yourself. Okay, once you come back, we're going to connect those with an exponential growth curve. So let's see, seems to be leveling out here around 0, like this. Okay, and normally the horizontal asymptote for exponential growth would be at y equals 0, unless it had been shifted up or down. So you can see, since it's leveling out at 0, that is where your horizontal asymptote is. So graph that too. The asymptote is an important part of the graph. Okay, now let's see. We said that our asymptote is right here at y equals 0. And our range starts where the arrow points over here at -infinity, and it continues. This arrow is going up, but it's also going slightly to the right, and to the right is +infinity. So my domain, oops, my domain is -infinity to +infinity. My range starts right after this asymptote, and it doesn't touch the asymptote, so I won't include 0. So the parentheses means don't include 0, and my range goes 0 to infinity. This graph is always increasing. It's actually an example of exponential growth. So increasing. And the end behavior. As x goes to -infinity, that's over here, that's the left side of my graph. Left. the y is getting closer and closer to the horizontal asymptote, so it's approaching 0. As x goes to positive infinity, that's the right side of my graph. This branch is going up, up, up forever, and so it's going to positive infinity. So in this case, the left is going to the asymptote, but the right is going to infinity. All right, so now that you've done this problem, you can try the next problem if you like before moving on. I'm going to move on to some different problems and come back to problem 2 in a different video. Okay, rewriting in logarithmic form. So if I have some base to the x power equals y, I can rewrite that as a logarithm. The base of your logarithm is the same as the base of your exponential, and then these two are going to switch order so that it's going to be log base b of y equals x. The answer to the logarithm is the exponent. So let's try the first one. I need to change this to a log, so I'm going to write the word log. The base of my exponential is the base of my logarithm, so that's 9. And then those two switch, so I have 81. And then I have equals 2. So when I see this, I'm thinking 9 to what exponent gives me 81? Oh, the answer's 2. All right, this one, same thing. Write the word log. The base of your log is the base of your exponential, which is over here, 1/4. Okay, these two switch so that next comes 1/64. And then the answer to your logarithm is your exponent. All right, so for C and D, try those on your own, and I'll go back to those on another video. All right, so now we're doing the same thing, but we're starting with logarithms. So I want to rewrite this as an exponential. The base of my logarithm is the base of my exponential. The answer to my logarithm is the exponent. That's going to equal 128. The base of my logarithm is the base of my exponential. The answer to my logarithm is my exponent. And that's going to equal 32. All right, so pause the video. Make sure you got those two. Try the other ones, and we'll come back to those in another video. All right, number 5. Evaluate the logarithm without a calculator. So the way I do that is I write equals x after it, and I rewrite it as an exponential. So 4 is the base, x is the exponent, and that equals 64. So 4 to some power equals 64. Well, let's think about it for a second. 4 times 4 is 16. That's not big enough. Times 4 again, 16 times 4, that's 64. So it's 4 to the third power. So that means, oops, erase that. So since 4 times 4 times 4 is 64, the x is going to have to be 3, because there were 3 of those 4s. Alright, so b is going to be similar. You're going to write equals x after it, and then you're going to rewrite it as an exponential and solve it, but I'm going to let you do that one on your own. So let's do number 14. It says evaluate without a calculator, because there's no integer such that 4 to that number would give you 211. 211 is not a power of 4. So the way you find your answer is with the change of base formula. And the change of base formula says do log of the big number over log of the base. So that would be log 211 divided by log 4. Now on the calculator, you're going to have to remember, put parentheses and parentheses. Okay, so pull up your calculator. And log is over here. 211 divided by log 4. All right, and let's round this to the hundredths place. So 3.86. Okay, and you can do the same thing for D, and then we'll move on to the next page. All right, for glass to be shaped, its temperature must be above 1200 degrees Fahrenheit. The temperature of a piece of glass is 2200 degrees Fahrenheit when it comes out of the furnace, and the table shows the temperature readings for the glass. Write an exponential model and find how long it takes for the piece of glass to cool to 1200 degrees Fahrenheit. Okay, so you can see that your answer is going to be between 10 and 15 minutes somewhere. But if we have this exponential model, then we can try to solve for that. So we're going to put this data in your calculator. Oops. Stat, and then edit your lists. If you have data in your lists already, you can go to the title of the list and press clear and then enter, and then that will clear out your whole list, and you can enter this data here. So pause for a minute and get all that data in your calculator. And then we're going to do an exponential regression. So we're going to press stat, calculate, and it should be choice 0. So if you scroll down your list, you should get there. Oops, there it was. Okay, so I have y is equal to 2,144. Since they're using integers, I'm going to keep that as an integer. But then I'm going to round my b also to 4 decimal places, so it'll be 0.9530. All right, let's move this over. And we have y equals 2144. And that number was 0.9530. Okay, so because this number is less than 1, I can tell that this is decaying. And you can see that from the chart too. It's getting smaller. All right, so we want to know when the y is going to be 1200. Now you could solve that algebraically. You can also solve that graphically. If you put this in your y equals, clear this one out, you have 2144.9530 to the x. And then we need to be able to see that in the graph. So I'm going to change my window. So my x goes from 0 to 2200. And let's see, what kind of y's do I have? Oh, no, that's my y's that need to go 0 to 2200. And my x's need to go from 0 to 25. Okay, so let's see if I put that in my y1. I did. Can I see that graph? Yeah, you can see it over here. So we want to know when the y is 1200 degrees. So put that in your y2. Graph that. And you can see that they're going to intersect at a certain point. Oh, I did 12,000, my bad. Y equals, go down, get rid of a 0. Okay, so now we should find out where they intersect. Okay, So to find this point of intersection, let's do second, calculate, intersect 5, enter, enter, enter. Okay, so it looks like when x is about 12, the y is going to be 1200. You could probably find that from the table of values also. See if we go down to x is 12. And we get really close to 1200 here. Okay, so x is 12 minutes. Alright, so in this section I'm going to do some of these problems with you and then leave you some to work on, and I'll do that in a second video. Alright, when you have an exponential equation like this, you want to check and see if you can make them powers of the same base. So I can make 9 into 3 squared and 27 into 3 to the third, so that's what I'm going to do. 9 is 3 squared, and notice it has a 3x plus 1 on it, and 27 is 3 to the third. And when you have power to a power, you can multiply your exponents. So I would multiply this, and I would get 3 to the 6x plus 2 equals 3 to the 3. Once your bases are the same, you know your exponents have to be the same, so just deal with the exponents. 6x plus 2 equals this 3 here. Subtract the 2, 6x equals 1, and divide by 6 to get x equals 1/6. Alright, in problem 8, 4 and 9 cannot be powers of the same base, so we're going to use a different strategy here. We're going to take the log of both sides. So I have log 4 equals the log of 9 to the 3x minus 2. And then you can use your power property to take your exponent and move it to the front. So you have log 4 equals 3x minus 2 log 9. And then you need to distribute the log 9 to this one and to this one. So I would have log 4 equals 3x log 9 minus 2 log 9. Alright, now if I'm going too fast for you, just pause the video and then come back. Okay, so then we need to get the x by itself, so I'm going to add 2 log 9 to both sides. So I have log 4 plus 2 log 9 equals 3x log 9. And then finally, you need to get the x by itself, so you're going to divide by 3 log 9. Now this is something that you can put in the calculator, but you need to get all your parentheses in order. So see, that cancels out the 3 and that cancels out the log 9. So for your parentheses, here's what you need. You need a set to keep your numerator together, and you need a set to keep your denominator together. Then you also need, what else do we have, purple? You need one around the thing that you're taking the log of. So log of 4, log of 9, and log of 9. So let's put this in the calculator. Okay. So clear out what you have, and you're going to type parentheses log 4 plus 2 log 9, close, close, divided by parentheses 3 log 9, and close, close. Okay. Alright, so we get about 0.87, let's round this up to a 7, so 0.877. Oh, and here it says 3 decimal places, so that was right. Alright, So problem 9, I'm not going to do that one right now, I'll do that in the next video. Decide whether you can make these bases powers of the same base like we did in problem 7, or if you need to take the log of each side like we did in problem 8, and then work that one out. Then come back to our video and we'll do problem 10. In problem 10, in order to solve this logarithm, we need to first get it by itself. So I need to get rid of the 2. I'm going to divide by 2 on both sides. And I have log base 4 x plus 4 equals 3. And now I only have a logarithm on one side. I don't know why that happened. Okay, I only have a logarithm on one side, so I want to rewrite it as an exponential. The base of my log is the base of my exponential. The answer is the exponent, and that equals 5x plus 4. So 4 to the third is 4 times 4 times 4, which is 64. And that's 5x plus 4. Subtract 4 from both sides. I have 60 equals 5x, and then divide by 5 to get x equals 12. Now when you solve a logarithm, you need to double check that it does not make this part in the parentheses negative. So you plug the 12 back in, and you do 5 times 12 plus 4, and it's positive, so you know this answer is okay. Okay, we're going to try, nope, problem 11 is just like problem 10. You're going to solve it with the same method, so I'm going to leave you that one, and we'll try problem 12. Now, if there's a logarithm on both sides, you can do something which is called exponentiate, which means you take the base of the log and you put that as the base of an exponential, and that will cancel out the logs. But a lot of people skip that step of writing the 4, and they just cancel the logs out. That's okay. You can do it because there's a log on each side. Then you take the insides, and those equal each other. So x minus 5 equals 4x plus 1. Subtract x from both sides. Negative 5 equals 3x plus 1. Subtract 1. Negative 6 equals 3x, and divide by 3. So x equals negative 2. So then you need to check it by plugging it back in. I can plug it into either of these first and then the other. So if I plug it into x minus 5, I would have negative 3 minus 5, which is negative 8. And the input for your logarithm here cannot be negative. So this answer is extraneous, and there is no solution to this problem. Alright, and so then you can try problem 13 in a similar way. Try that one on your own, and then we'll go back to 14 together. So this one is one that uses that model where your y is equal to your starting amount, and then your x is going to be plus or minus your rate depending on if you're increasing or decreasing. So since this population is decreasing, sorry, that's not an x, that's a 1. 1 represents the whole of your population. So that would be 1. And it's going to be minus your rate because you're decreasing, and that's going to be to your time. Alright, so your starting amount was 1,205 people, and your rate is 2%. 2% as a decimal is 0.02. So that would be 1 minus 0.02 to the t. Now when you subtract that, you get 0.98. So you have a model of 1,205 times 0.98 to the t. So this is your model. And now we need to use the model to find the population in 2030. So 2030 is how many years after 2000? 30 years. So that's going to be the time you're going to put into the equation. So on your calculator, you're going to type 1,205 times 0.98 to the 30th. Alright, and so we have to round this to the nearest person because you can't have 0.3 people. So we will say that this is 657 people. Okay, so that's the end of the first video. If you haven't tried the other problems yet, please try them before watching the next video.